Okay, let's do serverless. Okay, here's the check-in. So first of all, what are you responsible for if you run your code on Lambda, which is the serverless service, which we talked about briefly before? What are you responsible for? That's it. You've got A. Oops, sorry. But now, were you going to say something?
Everything, right?
If you run your code on Lambda?
No. Sorry, you're right. Hey.
Yeah, you're just responsible for writing code. Everything else they handle. Because it's not even really serverless, right? It's like a highly managed service. So it's like there's not even an option of having servers. So everything's just done through the API. So you upload your code and you set the triggers, you set the execution permissions, you're done. You don't have to scale it. You don't have to OS patch it. You don't have to manage the servers. The only other thing that you have to pay attention to is how many concurrent executions of Lambda are you running. By default, I think you only get 1,000 concurrent executions. If you run above that, by the way, you're going to get blocked. They're not going to run. Right? So just something to keep in mind. So you're just responsible for writing code. All right, so then let's talk about serverless. So here's the deal. We want to optimize spends. We got a bunch of stuff running using virtual machine models that don't necessarily need to be in virtual machines because they're little one-off functions and executions. Plus, we don't really want to deal with servers, and we're looking at event-driven architecture. And we also want to know that if we decide to go this route and use serverless, are there other tools that we should be aware of if we decide to go this road? Are there other supporting systems like messaging queues and notification systems and API gateways and orchestrators for Lambda that we can use that make this easier for us? So how do I build an event-driven architecture? How do I connect my applications to AWS services? How do I send text messages? How do I process a lot of streaming data in near real time? How do I set up a multi-step workflow? And then the other thing is, I just mentioned this, is that what if I need a queue? Like, what are my options for that? Now, I'm going to blow your mind for just a second because I'm going to just show you a serverless architecture. So just hold on for a second. So here's a serverless architecture. And just so you know, if you go to the far left, there's a commerce platform, which then has order and customer updates, which is an updated table, which in turn triggers some kind of Lambda function that triggers into EventBridge. That might, for example, relay a customer login, right? It might submit an order. It might do an order completion. Like there's this whole workflow that gets orchestrated. And notice that Lambda is all over the place here. EventBridge is at the center, which I may have told you that EventBridge is built for event-driven architectures. And then notice that there's like tables all over the place. But there's also that first in, first out FIFO queue, which is an SQS queue, although it could be an MQ, an active MQ queue as well. But that's a queue where you just dump messages on there and they get processed, right? That's what it's for. So this general serverless architecture, like what are things that we can put in here to actually make this even more palatable and easy for us to use? But first we need to talk a little bit about serverless. But this is a classic event-driven architecture. Someone does something, this triggers a bunch of events, and as they continue to trigger things, things happen. Inventory is deducted, things are shipped, payment is processed, like all of these different workflow steps are executed. So serverless is nothing more than, in this particular case, functions as a service. This is code that runs for 15 minutes or less, even though it can be chained with a bunch of other code executions. And what this does is this sets us up for some kind of portfolio for a product, right? Now, in addition, AWS itself, right, in addition to having these workflows that are all part of a product workflow, a product portfolio, we basically have these tools that can also support us in setting up Lambda. So I don't know why Fargate's listed there. I think what they're trying to say here is that all of these servers are serverless, but I want to draw some distinctions here. all of these are API driven services with really no connections back to a database or back to a Kubernetes engine, except for Fargate and except for Aurora. So let me be clear, is that Aurora and Fargate do actually require you to connect to something else, like an RDS engine or a container, right? Which is a little different than calling the S3, I'm sorry, the AWS APIs. The rest of these are all API driven. Okay. Confusing. All right, so here's another example of a serverless kind of event-driven architecture. Notice there is not a single EC2 instance listed here. Someone uploads an inventory file. That inventory file is then, processed, and the results are dumped into a DynamoDB table. Then a dashboard app is going to query that DynamoDB table. Lambda is going to receive the table updates in a separate path, trigger out an SNS notification that's going to let the user know, hey, we got your inventory updates. They're ready to go. Notice the workflow here. Not a single server in sight. No operating systems in sight. Just high-level AWS services. This does reduce the total cost of ownership. It does require, obviously, some orchestration knowledge to pull off, but not a whole lot, honestly. Not as much as it would take if you were going to have to manage a fleet of operating systems and patch them and maintain them and all that stuff. So let's talk about some of these adjunctive services that can support that serverless architecture. First and foremost, let's talk about the load balancer. Load balancer. Did I just say load balancer? Let's talk about the load balancer. We'll do that intentionally. That will allow you to connect to an API, right? So when we're already familiar with talking to APIs because the web console is just a skin to talk to the API. The CLI is just a skin to talk to the API. And the CDK, SDKs, infrastructure as code, that's all just vehicles to talk to the API. Now, the API gateway is a service that's very similar to an application load balancer, not necessarily because it does load balancing and distribution, but this gateway is like think of it as a more simple cousin to like MuleSoft, Apogee, those API gateways that you can buy, like Apogee's owned by Google. I think MuleSoft is still independent, but there were a couple out there for a while. Kong wasn't the old name. Anyway, my point being is that the API gateway, it allows you to maintain, publish, create, monitor, and secure APIs. You can also monetize them. You can monetize your APIs with API gateway. This does REST and WebSockets. So, and it will do hundreds of thousands of concurrent API calls. This includes, by the way, traffic management, authorization and access control, version management, staging. This is a really robust, awesome product. Yeah. So single front end to manage all of your different versions and stages of your API, throttles, meters, monetize, will actually scale and provide distributed denial of service protection and throttling and metering and whatnot. Here's an example, gateway architecture. You got clients coming across the internet. CloudFront is fronting the API calls. I don't know if most people don't know that, but CloudFront can actually front API calls. Most people are not aware of that. They think it's only for static content and for static objects, but CloudFront can actually front API calls as well. And by the way, it can modify the response of those API calls. And then it hits the gateway, which then can, talk to a cache of some type. Because let's say you've turned on caching on the gateway. It's obviously dumping all of its metrics into CloudWatch. It might authenticate with Cognito, which is the application authentication service. And then, it can invoke a Lambda function, which can talk to a DynamoDB database on the back end. So, this thing has a ton of features to it. So the API gateway is a huge beast of a service. Note that you can modify both the response from client, response back to the source, like the integration call back to the original source, the response from the integration, and your response to the client. So you can modify what's received and what's sent back as well. So yeah, it's a good product. Complicated. you've ever done a lab on API gateway, that's a fun one to do. So remember, API gateway is basically your like cache, meter, monetization, and traffic management proxy for any APIs that you want to run. And that includes Lambda, or that source could be an EC2 or container. So don't get hung up just on serverless. API gateway will feed out any API source. Now, we're going to talk about two sister services, SQS, which is a poll model, and then SNS, which is a pub sub model. So we're going to talk about these two services, which do very different things, but are considered like kind of sister services to each other. One allows you to dump messages on this queuing service, and you get to go and poll the service and pick up these messages. Now, these messages are stored until they are processed and deleted. And if for some reason a message can't be processed, you can send it over to what's called a dead letter queue that allows it to be picked up by, like, what's the aberration? Why couldn't you process? The job of a queue like this is to act as a buffer between, say, your web servers, which are dumping a bunch of order requests, and your application servers, which are having to process those order requests. So this is a great way. If you get a surge in messages, you don't have to overwhelm your back end. You just put them in this queue, kind of like if you're at a diner, there's a huge rush at the diner. All of a sudden they go from 3 orders to 50 orders. They can just process those orders as they come and not get completely overwhelmed, right? So you got a queuing system for how to manage and set up these orders. Now, without Amazon SQS, what will happen is that your front end could easily overload your back end. It can happen. If you throw in a queue, though, what can happen is that your front end can dump all of the messages it wants inside this queue, and then your back end can just process or consume these messages as it can. Here's the other cool thing, though. SQS queues can trigger autoscaling. So almost like how a load balancer can trigger autoscaling, or if a statistic can trigger autoscaling, SQS queues can trigger an expansion with autoscaling if it's not happening quick enough. Like if the orders aren't being processed, or if the queue gets really deep, SQS can say to the autoscaling group, hey, I need you to double the amount of servers based on whatever policy you've set up, right? So SQS can actually trigger autoscaling as well, which is pretty cool. Now, this is a great example architecturally of loose coupling. Because what you've done is you've abstracted away connections between the producer tier and the consumer tier. They're no longer aware of each other, which means they can be independently scaled. And that message bus is where they like share that communication point. So there are great use cases here for work queues, buffering and batch operations, auto scaling, obviously, which I just mentioned, and request offloading, right? So this allows you to approach this kind of thing easier, quicker, faster. This, by the way, is a highly managed service. You do not see any servers at any point in time. And you can have a standard queue, which means that things are processed at least once, but it is unordered. Or you can have a FIFO queue, which means things are processed only once and things are ordered. So as things are put in, that's the way they're processed. Now, with standard queues, there's nearly unlimited API calls per second, right? With FIFO queues, you are limited, and I can't remember what the exact number is, but it's like, I want to say it's like 300 API calls per second or something like that. Don't quote me on that. Gotta look up those numbers. But with the FIFO queue, there is a limit, right? There's a low limit because you're asking for structure. You want to enforce structure, right? So SQS, by the way, also has lifecycle and visibility timeouts. You can do short and long polling. I mentioned dead letter queues already, which basically says if something isn't processing, put it over here and let's go take a look at it. Now, what happens is that someone will produce a message, and invisibly to you, it'll go across all of Amazon's SQS servers, like 5 or 6 of them. What happens is that this message gets replicated so it's not lost. So if a server fails, you're not going to lose the message, right? Now, what happens is that the consumer on the back end comes and says, hey, SQS, do you have a message for me? The minute that message is picked up, it still stays on the queue, but it goes invisible. That way, if that consumer server fails, the message will hit its visibility timeout, become visible again, and another consumer can come pick it up. This guarantees that the process is read at least once. And by the way, you cannot delete a message unless you've read the message first. You have to have a read receipt. Now, this message is going to be invisible by default for 30 seconds. In our example here, they set it for 40, by the way. You can actually set a visibility timeout of 12 hours if you want to. And by the way, you should memorize that if you're taking the exam. 30 seconds is the default message timeout for SQS, meaning the visibility timeout is 30 seconds, not the deletion, the visibility timeout. So it'll live for 30 seconds. By the way, the deletion timeout where it will actually delete the message, I believe is 14 days is the max. So by default, I think it's 24 hours.
Sir, one more time, what does this visibility timeout do?
The visibility timeout makes the message invisible once it's read. So it doesn't delete it. It makes it invisible so you can't see it. And so what happens is that once that visibility timeout goes back to 0, the message becomes visible again so someone else can pick it up in case the original server somehow is lost.
I see. So the expectation is that within that visibility timeout, the application will be deleted or processed?
What will happen is that it'll process what the message is delivering, and then it will delete the message off of the queue.
Gotcha, gotcha.
But if for some reason it fails and doesn't delete the message, then the message becomes visible again, and then another backend processor can pick it up.
Gotcha.
And you
I
might
wonder,
go ahead.
sorry, sir. I wonder what happens, like if it took longer than the visibility timeout, will it increase the visibility timeout or what happens?
If it takes longer than the visibility timeout, what will happen is that the message will become visible again and someone else will pick it up. And so that's why you can get duplication of processing. So in order for you to do that, you have to know like what's the longest your application could ever take to process this particular thing. Or you can just use a FIFO queue. A FIFO queue will guarantee that that message is only processed once. In other words, it'll feed out the items in order. And if the item doesn't get processed, it will surface that same item again, but it will only do that once it knows that the item is not being processed. So there's a different kind of step process that gets followed with FIFO queues to guarantee that it only gets processed once. So visibility timeout expires, message can come back available again, but hopefully, if you know how your application, what the longest time cycle is for your application, the application consumer will come back and delete that message before the visibility timeout comes on. If that doesn't happen, then just tweak the visibility timeout and set it high. Now, the other thing that could happen there is that you might have a delay with a message because it's not getting processed because you lost a host or you lost a whole suite of systems. But again, just a little bit of architecture will make that work. So to restate that, you should set the visibility timeout to the maximum time it takes your application to process and delete a message from a queue. If you're like, well, that's an hour and a half, then you set it to an hour and a half. So the max, by the way, is 12 hours. So just as a reminder. Consumer must delete the message after it's been processed. That's true. If you don't delete the message, it's going to become visible again and someone else is going to process it again. The other way that people get around this, by the way, is that when a consumer picks up the message, it'll actually go check a DynamoDB table and say, hey, this is message number 57. Has this already been picked up by somebody else? If it sees that it's been picked up by somebody else, it'll just drop it on the floor. Or it might mark it for something that it might check later after it processes another message just to make sure, right? So just know that there are other mechanisms from a programming perspective that you can do to ensure that messages in a standard queue are not processed twice. All right, so let's say the message has been processed. The other thing to consider is that how did you come and ask whether or not there were any tasks for me to do? So if there's, like, for example, 9 servers who are possibly storing messages, and you come over and say, do you have any messages for me? You're going to probably get at least one message, because it's like knocking on the door and on the other side are 12 people and you only talk to 3 of them. Hey, do you have a message for me? And these 3 people are like looking at each other going, no, I don't have a message for you. We're done. Long polling is different. Long polling is you go into the door, knocking on the door and saying, hey, do you have a message for me? And instead of the person looking at the 2 people around them going, hey, do we have any messages for this guy? They walk back and talk to everybody in the room and say, hey, does anybody have a message for this person? Right? Notice the difference in messages received here. A, B, C, D, and E are all received. But back here, somebody might get A and B, somebody might get nothing, somebody might get the C message, somebody might get nothing, somebody might get the D and E messages. So long polling is preferred, short polling is the default. But long polling, if you're single threaded, is going to tie you up. But let's just say it's 2021. If you're writing a single threaded application, we should talk. I have free consulting for you. Okay. So ideally, you're using long polling. Dead letter queue I already mentioned. So different from short polling and long polling. This is where if something just can't be processed, it is failing to get processed, you can actually say that after a certain number of failures, just go over to the dead letter queue. And then what you can do is you can have your application randomly check the dead letter queue to see if something's sitting there. Or maybe you have a different application that follows a different series of steps. Or maybe you have someone go manually look at it. Just depends on the number of dead letters that you're getting, right? Now, so what do you use these queues for? Well, one, service to service communication, asynchronous work, just as a buffer between front end and back end, state change notifications. Notice that these messages are limited to 256 kilobytes in size. You are not going to be putting a massive amount of data on this. You know, I know some people have written kind of like hacks to put like gigs of data on these things. No, don't do that. They are fraught with peril. By default, a message inside of SQS is 256 kilobytes in size. If you need more storage, then just refer to an S3 link inside your message, right? Has an idea. So that was all the simple queuing service. Be aware that that is proprietary to Amazon. They do have was it managed MQ? Basically it's an active MQ cluster. So that's more industry standard. So if you need like MQTT or oh, I forgot the protocols now. AMQP. If you need like standard, like more IoT level, I'm sorry, Q protocols, not IoT level protocols, Q protocols, Amazon does have an MQ service. Actually, let's go take a look at that. Over here trying to pull it from memory, I should probably just go look, right? Well, let's go take a look. All right, so let's go to console home actually really quick. And although I might be just search for MQ, let's see. Yeah, Amazon MQ. So there's a managed message broker, right? This basically is, it used to just be active MQ, but they added a new flavor. So a RabbitMQ is here as well. And so this just uses standard protocols. So if you needed an industry standard messaging bus and you don't want to use SQS and you don't mind a little bit of lack of availability and a little bit of a lack of more operational overhead, then just know that you can actually use ActiveMQ and RabbitMQ as your brokers, okay? So if you need industry standard, I would use this. Otherwise, I would default to using SQS because it's just so easy to use. So just saying that. Okay, last little set here. Actually, you know what? Let's take a break.
I was like, Mike, can I ask you a real quick question on that MQ that you were just on?
Yeah.
I was reading the pricing policy on that, and it says you only pay for the time the broker is up.
Uh-huh.
Right. I mean,
Well, it's three posts, right? It's the message broker, the storage that you're using, and some transfer fees.
okay. Yeah, when wouldn't the broker be up? So, all right, just thought I'd ask.
Well, remember, Christian, these are all disposable resources, right? So you might spin it down and spin it up.
Sure.
You did not sound convinced at all. You're like, really, Forrester? We're gonna spin it up and spin it down. Yeah.
I mean, I could use a Lambda to spin up the broker, but then I'd have to have a messaging service to tell them. I mean, you know.
Yeah. I get it. Yeah, and I would say that, in general, when you create these infrastructures, you're not spinning things up and down unless you're spinning the whole thing up and down, right? That's why I think SQS is a better option, right? It's cheaper, lower overhead. It meets most use cases. But if you need industry standard protocols and you don't want to use the AWS API for that, you got to use either roll your own or just use that MQ, right? Yeah. And by the way, it gets even worse when you decide to add high availability, because then you got 2 instances running. So there's that. All right. So it's 10:32 right now. Let's come back at 10:45. We'll finish out these last 3 pieces. We'll do a lab. We'll go to lunch. We'll be done. Okay. So let's stop. I'll put up a timer. So let's come back in 13 minutes. So at 10:45. Okay. All right, so SNS. So SNS is the sister service to SQS in the sense of we're familiar with SNS because we basically subscribe to topics. People publish messages to those topics, and we as subscribers receive messages. We're familiar with this with email, right? We sign up for these subscription lists and we get these emails all the time. SNS is very similar to that, but unlike the simple email service, which is used for bulk messaging, yes, there is a simple email service. It's been around for a minute. Unlike the simple email service, SNS will notify through a bunch of different vehicles, including Lambdas, including web posts, including texts and messaging, right? So SNS will do all kinds of alerting functions. It is a notification system, but like any notification system in AWS, it does a lot. So you get a single published message. You can't recall it. It will retry if it's a web post. And you can then, it does have standard or first in, first out queues, just like SQS does. A couple of things to think about from a distinction standpoint is that, you can actually publish 2 SQS queues. You can actually publish 2 Lambdas, and this allows you basically to duplicate a message. SQS does not do message duplication. It tries to avoid duplication if at all possible, but SNS actually does do actual message duplication, right? That is a good question. Am I sharing slides? So this is the characteristics. So SNS, here's the topic. Going out to subscribers. Here's the general use case as far as like system alerts, email, text messaging, mobile push. And then here is, single publish message, no recall options. It will retry web posts, and it does do standard or FIFO queues. Thanks for by the way, for saying something. So it will publish to multiple queues. It can also publish to Lambdas. It will publish to web servers. It will publish to email. It'll publish to SMS, right? And SNS and SQS, right, are very different in how they approach message persistence. SNS is going to drop a message on the floor. SQS will not, right? SQS is going to keep a message until it hits its deletion timeout, right? The delivery mechanism for SQS is very active. In other words, you subscribe and it's going to push it out. Now, the difference with the polling model is that the publisher just puts the message out there. The consumer has to come and talk to the SQS queue in order to get that message. So the consumer has to come. When it comes to the consumer on the SNS side, you don't actually have to do anything. You've already signed up. That's the first thing you have to do. So Amazon SNS is pub sub, and SQS is basically a push model. Sorry, a poll model, not a push model, a poll model. So SNS is designed to take a single message and duplicate it out. SQS is supposed to be a one-to-one relationship.
So, sir, if you were to compare SQS or SNS with, excuse me, if you were to compare Kafka, hoping you know Kafka, which one that will map to SNS or SQS?
Kafka doesn't match it to actually to either one of those. Kafka actually maps more to a service called Kinesis, right? But if you had to pick one, it's probably more of like a streaming queue, right? It's probably more like SQS just in terms of like there's ordered messages like stuck onto a stream, right? To a data stream. But it's more like Kinesis, which is actually the next thing we're going to talk about. So Kinesis was Amazon's streaming kind of real-time analytics data bus, data messaging service, right? We want to call it, before Kafka hit popularity. So I wouldn't say that SNS and SQS are similar to Kafka. I say SQS is probably the closest.
I see.
Now Kinesis, so we're moving away from SNS and now on to Kinesis. Kinesis is different because, this is, like Kafka, this is built for streaming data, right? Which in a sense is just a bus that, you can actually just almost like time order can just like sip the different pieces and parts that you need, right? So Kinesis, much like Kafka, is really for like collecting, processing, and analyzing data streams in real time, right? So if you ever see a question that says, hey, I'm looking for a real-time data processing stream, you can use Kinesis for that. Now, I just want to forewarn you is that Amazon has had for a while an MSK, a managed Kafka service. I think it's like managed servers for Kafka. MSK is what they refer to it as. So managed servers for Kafka has existed for a while, like maybe a year, maybe longer, 2 years. So they have a managed Kafka service that you can use other than Kinesis, but Kinesis is their native tool. Kafka obviously is more of an open, source tool. Now you see that they have Kinesis data streams, which is really just for streaming data for analytics. They have Firehose, which is about streaming data into data repositories or data stores. Then they have data analytics, which will actually dump it, data streams into SQL or Apache Flink, sorry. And then you have Kinesis video streams, which is just really about collecting video streams for analytics. So analysis of images, transcription, that kind of thing. The main thing that you probably want to just be aware is that if it says data streams, it's for analytics. If it says video streams, it's for analytics. So the streaming pieces are for analytics. Data Firehose is for dumping data into data repositories, and the Kinesis data analytics is specific to use with either Apache Flink or Microsoft SQL. So this is great. These are great use cases for video data, audio data, application logs, website click streams, IoT, telemetry data. So, with Kinesis data streams, the first one, what happens is that data producers like website, clicks or whatever, will go into the Kinesis setup. It's going to hash that data and it's going to stick it on a shard. A shard, if I remember correctly, can like read up to 1 megabyte per second of data, and 2 megabytes can be like sipped off of it. In other words, it can ingest and express data. Each shard makes up the stream. So shard 1, shard 2, shard 3, shard 4, etc. Just know that you can have multiple shards. Your data is automatically parsed and hashed and put on one of these shards. And if you want to increase the bandwidth of your stream, you have to split shards, and split shards, because every shard you have can handle this much bandwidth. So if you need to get 10 megabytes of ingestion, you're going to need at least 10 shards. And what will happen is that as you split those shards, your data is going to get partitioned and hashed across those 10 shards. You can also condense shards, which also means that your data will get like categorized differently across those shards. So adding shards, splitting shards, and consolidating shards is how you expand bandwidth inside of a Kinesis data stream. Now the consumers on the back end can sip data off of whatever shard or partition they want, and then they can dump it to wherever they want to. Now, if you're using Firehose, you can just dump that data into a data repository. You don't need to have an application there. You can just dump it right in. So data, by the way, can be batched and compressed before loading it. You can also do some ETL on it if you want to. So just know, we only talked about data Firehose and data streams. We didn't talk about Kinesis data analytics, and we didn't talk about Kinesis video streams because those are more advanced use cases. So data streams and data Firehose are the two things, at least for the exam, that they're going to ask you about. The main thing to know is that Kinesis is used for real-time data collection, data streaming. That's what it's used for. All right, so Kinesis, real-time. SNS, simple notification service, right? Used for notification, pub/sub. SQS is a messaging queue that allows loose coupling and asynchronous messaging. Both SNS and SQS have standard and FIFO queues. API Gateway is basically a caching, metering, and throttling load balancer for APIs. So then the last thing we're going to talk about is step functions. So step functions allows you to basically coordinate Lambda functions together. Now, it doesn't just do Lambda, but it basically allows you to define microservice workflows, lets you step through the functions of your application, allows you to initiate, track each step, and then of course you've got all the error, caching and logging. This is basically a state machine. Its job is to support you defining and walking through your different processes. So, either waiting for a transaction, selecting a soda, vend the soda, like simple processes like that. And it uses this state language that allows you to define the start of the workflow, the next state of the workflow, the next state of the workflow. And by the way, those workflows could be parallel workflows. They could require approval. Here's an example. Here, like what we're doing is that like they're starting to verify identity documents and check address. Does it require a human being to review it? Yes. Okay, good. Then we're going to wait for the review. Was it approved? Was it not? Like these are the kind of workflows you can define. This allows you to define an event-driven architecture. Here's a better example. Data gets posted into an API gateway, which triggers a Lambda function like a state machine, so a step function. And they're going to look up the customer number, generate a reference number, record the transaction in DynamoDB. And notice in the first step, they actually looked up the customer number in a DynamoDB database. And then did they record the transaction? Were they successful? Awesome. Great. Let's move on. Did they fail? Okay, good. Let's notify an admin that we had a failure, right? When posting this form data. Now, I don't think this is a super complex workflow, but it's definitely a good example. This code, by the way, could be run many times. You could have a JavaScript client that posts that data into that API gateway, and you can have 1,000 clients doing it concurrently. The API gateway would handle it, and the step function would create a state machine for each of those 1,000 workflows. So just know this is a system that scales very, very well.
So this reminds me the business BPM solutions in good old days. Is that true?
Like business process management?
Yeah.
Yeah. Well, that's what it is, right? It's that you are technically defining your business process, but you're putting technical associations with it. So yeah, I would say, kind of like Sean earlier, you made a statement like this is an org that knows its use case. Obviously, this is an org that knows its workflows, right? So Vinod, to answer your statement, yeah, it does require you obviously to know your business processes and your technical workflows.
Right. And sir, did you just say that this can scale? So what this can scale?
Oh yeah,
So if I write a step function with all these different steps, and if I have like let's say there are hundreds of API gateway calls coming in, it can scale automatically.
yeah, making sure that you're taking care of your limits. Of course you can. What do I mean by limits? For example, if you need 1,000 concurrent Lambda executions or 10,000, you have to just make sure that your account is set for that. Amazon doesn't let you run 10,000 concurrent executions out of the box because it doesn't want you to overpay or hurt yourself if you get hacked or something goes wrong, right? So just the only thing you'd have to just make sure that if you set this kind of thing up is just make sure your service limits support it. You have to make sure that DynamoDB has enough read and write capacity units, or you can just set it to auto scaling. SNS scales automatically, so you don't have to worry about that one. So really it's just making sure your Lambda functions have enough concurrent executions and that your DynamoDB has enough read and write capacity units if you're not using auto scaling. That's it. The API gateway, by the way, will go to hundreds of thousands of connections a second.
How about step functions itself? Could you run multiple instances of the same step function?
Oh,
concurrently?
you could run tens of thousands, if not hundreds of thousands.
Wow.
Yeah. Again, it's all about what your account limits are set to. And that's easily navigated with AWS. You just send them an email, like a support request or a ticket, or you can go into the quotas dashboard and ask for a lift on your quotas. Yeah. Just so you know, quota limits are in everybody's account so that if someone accidentally does a runaway execution, you can't just break the bank. Imagine if all of a sudden you had a recursively run Lambda function that tried to run 1 million concurrent executions. Amazon does that just to make sure that like you could actually get into some expensive dollars, right? So they put limits on how many virtual machines, how many EBS volumes. So you just have to make sure that you're not running into your service limits whenever you try to do a large scale application. Otherwise, the sky's the limit. And Amazon does not put you through a lot of headaches for that. You just tell them you need it and they typically give it to you. So. Okay. Just do some knowledge check. Which type of Amazon SQS queue provides at least once delivery, right? Not only once processing, but at least once delivery. Good. Okay, so B, standard queue, right? If it was at least once processing, that would be FIFO queue, right? Or sorry, only once processing, that would be FIFO queue, right? Okay, what's the advantage of long polling compared to short polling? What is the advantage of long polling, which is where you talk to every server involved in your SQS queue, versus short polling, where you only talk to a few servers that are inside your SQS queue? What is the advantage? All right, I see some people posted C. Long polling reduces the cost of using Amazon SQS by reducing the number of empty responses and false empty responses. That's accurate, right? So imagine like you go to a room, you got 12 people in there, you're only talking to 3 of them. That's short polling. Long polling talks to all 12, right? So that if someone like has a message for you, long polling is definitely going to guarantee that you get it. Okay. What is a feature of Amazon SNS? Right? Does it use the polling model? Can it send messages to distributed components without requiring each component to be concurrently available? Can it push messages to multiple subscribers? Can it keep messages persistent? Good, see some posts here. SNS can indeed push messages to multiple subscribers. Good, that's the end of module 11. Any questions at all? Go ahead.
But the B was a bit confusing too, right? The B, option B here.
Without requiring each component to be concurrently available?
Oh, so it has to be available. I see.
Well, I mean, you can send messages to distributed components of applications maybe through like a web post, right?
Mhm.
But its main focus is those to them, that's just subscribers. So that's a web post. So the application has to subscribe to it, right?
Yeah.
Without requiring each component to be concurrently available. Well, if it's going to do a web post, then it's going to have to be available, right?
Right, right. And SNS does not keep sort of like SQS can keep for, I think I've heard 14 days, something like that, right? Like
Yeah, the
at least.
maximum. Yeah.
Yeah, and SNS does not keep it at all. It's just that passes on to the subscribers.
Yeah, it's going to
Right.
push it out to the subscribers. The only case where it might retain a message is if it's in a retry state where it's trying to do a web post,
Huh.
but you can't see that message and you can't do anything to that message. It's either going to go through its process of retries or it's going to fail. So for all intents and purposes, it's not keeping the message because you can't see it or do anything with it. And you can't recall it. So SNS does not keep messages.
Mhm. So another question, sir. Sorry.
That's good.
So I know you talked about Amazon MQ, which is like a managed service for ActiveMQ or RabbitMQ.
Mhm.
So is that is it Amazon MQ? Is that an alternative to SQS?
That managed MQ service?
Yeah.
I mean, yes, it is basically an open source alternative to SQS, which is proprietary to AWS. But I want to be very clear. Amazon MQ and SQS work very differently.
Oh,
They work differently. So if you're used to using ActiveMQ and RabbitMQ, you can just spin up Amazon MQ and just use it. It'll give you an endpoint ID and just a broker ID and you just connect to it.
So, sir,
SQS is all through the API.
Sir, we have a use case, like we have a customer who has been using ActiveMQ for quite some time,
Mhm.
and they're using containerized version of ActiveMQ.
Mhm.
And they, every so often they have one issues or the other. I was wondering what in AWS cloud we do, where we use Kubernetes platform. In AWS cloud, what would be an alternative to using ActiveMQ?
Well, if they're used to using ActiveMQ and their applications are written to talk to ActiveMQ, then you either need to host ActiveMQ into one of the 3 ways we can host applications, which honestly, there's only 2 for ActiveMQ. There's either containers or EC2, or you could use the ActiveMQ service.
You mean
So
Amazon MQ?
yeah, Amazon MQ. Yeah.
I see. Okay.
But so you can either host it yourself, either in your own containers, either in ECS or EKS, or you can host it on an EC2 instance. That's just up to you.
Got it.
Otherwise, you're going to have to use the Amazon MQ service.
Okay.
Yeah.
And alternative to Amazon ActiveMQ. So, sorry, I'm taking longer, I guess. An alternative to ActiveMQ could be Amazon MQ and not necessarily SQS or Kafka. Is that correct?
That's correct. But remember, you can also get a managed Kafka service if you want to do that instead. You can also, since the Amazon MQ service does support ActiveMQ and it does support RabbitMQ, you could go that route as well, right? If you switch to SQS, they're going to have to change the library that they're using to actually push and talk to the messaging bus. So the queue system. So there's a little bit more application rewrite if they do that. If they stick with ActiveMQ and just use the Amazon MQ service, there'll be very little rewrite. I think all they have to do at that point is just change either the authentication and the broker endpoint.
Gotcha. Thank you.
Yeah. Yeah. But if they're already rolling in containers, it's shocking the number of people who are like, well, we're not going to a managed service because we already roll it inside of a container. But I got to tell you, running data stores or even queues inside of a container, I would not be surprised that they're having trouble. You can do it. You just have to be skilled at it, and so it requires like 2 or 3 years to get really good at that kind of thing. Otherwise, running data stores inside of containers can be difficult. It's not It's easily done if you know what you're doing. If you've never done it before, it's really hard. That's true for most things, is it not? Hope that's not, those aren't like spectacular words of wisdom, right? Oh, Timothy, I can't even talk about Kafka on Kubernetes. Like
I
that,
appreciate your, I
Yeah.
appreciate your candor.
yeah.
Yeah, appreciate it.
I mean, if it was up to me, I try to make my worlds easier. Vernad, I actually, it's not that I love AWS. Let's be clear. I mean, I know I'm an instructor and all this other stuff, and I do a lot of consulting for them. It's because, any of these services make our worlds easier. This is the only reason to do this. And so like, the problem is I run into people who are like, well, we just don't run managed services. And it's like, okay, good, cool. Why not? And it's not a security compliance thing. Like I was talking to Christian the other day. Christian had valid reasons as to why they couldn't use managed services. That's totally legit. But most of the time I run into people and they're just like, well, we just can't. We just never done it that way. This is the way we've always done things, right? And that's the reason why I'm in business transformation, is because of that statement. This is the way we've always done things, right? Anyway, get off my soapbox. All right, here's what you're gonna do just for lab 5, because I'm a little worried that the labs are gonna expire because they do that sometimes when I pre-warm them. This looks like a lot. It's not. Here's what you're gonna do is you're gonna create the SNS topic, right? You're gonna create 3 SQS queues and you're gonna subscribe them to the SNS topic that you created over here. Then you're going to create and configure 3 Lambda functions, which by the way, this is all provided for you. So you're not going to be coding. So don't freak out. And they're going to upload an object to the S3 bucket, which is going to trigger the SNS topic, which is going to trigger the SQS queues, which is going to trigger the Lambda function, which is then going to trigger an output. Okay. I'm just going to forewarn you right now. Please, please, please check your console and make sure it says US East 1 whenever you're creating any of these objects. I need your eyes to constantly be, am I a Virginia? Am I a Virginia? Am I a Virginia? Just check it before you hit the create button. Because if you create any of these objects in any other region, it's not going to work. So, oh, hey, there's the steps. Just kind of rattle that off. All right. So here, if we open the lab, SNS topic, 3 SQS queues, S3 event notification to SNS. That wasn't in the list that I rattled off, was it? Configured 3 AWS Lambda functions, upload an object, and then validate the process file. So go ahead and hit start lab if you haven't already done so. There should still be. You're not gonna, okay. Anyway, it's not doing the 9 labs like I asked it. So I would say go ahead and let's take a run at lab 5. This lab, if I remember correctly, is typically, is it 45 minutes? Or is it 30? Yeah, it's a 45-minute lab. So building a serverless architecture, this is what we're doing, okay? So you're gonna build a serverless architecture, gonna take 45 minutes. That's gonna be the remainder of our time. See, my timing's actually really good. So once you're done with this lab, you're gonna go to lunch. We're coming back at 1:03 p.m., okay? But meanwhile, go ahead and get cracking on this lab. And then, oh, hey, look at this. They added an appendix to this set. Hold on one second. MQ, message broker. MQ is not a serverless solution. Hey, look at this. I'm gonna record this so you can see it on the video. You've got MQ, so you can replicate active MQ on premise with on-site. I knew that already. Oh, if you want to set high availability. So, hey, look at this. There's actually some MQ stuff here, actually. I didn't see this in this is a new version of the architecting class 7.04. They must have added this appendix. So this should be in your slide notes, including the difference. Oh, there it is. AMQP, Stomp, MQTT. Those are the protocols I couldn't remember, right? So just know that MQ supports the industry standard like JMS and NMS, right? That's listed here. SQS really just supports the API, the HTTPS API protocol. So, yeah, so there you go. So you have it in your appendix, just in case you need it. Okay. Let's get cracking on lab 5. I will check back in just before lunch and know that I will be here to answer any questions.